So now let's look at the second part of the demo in which I want to share with you how you could use the power of LLMs to do matching between a study and maybe a data store that you have of patients. To show this, the way that I want to share this demo is I went and I pulled in synthetically generated patient data from Cynthia. It was in file format. I took that data and just to make it easy to process, I loaded it in a Postgres database on Azure, managed Postgres instance in Azure, and that's the data set that we will comb through for matches. The actual study information will come from clinicaltrials.gov and it'll get augmented with any other information that we have. And what I want to show you is a way in which I just extract the inclusion exclusion criteria from the study and then run it over the database of patients that we have and come up with matches. The idea is that you can sort of kind of see what out of the box an LLM is capable of doing. And if need be, you can use other techniques to complement this and can use this as a starting point for a trial matching engine, if you will, that you can automate and then feed a subset to a human investigator who can further investigate the short list that they get, and this helps us quickly identify potential patient populations we can go after. Um, Literally, the LLM has not been trained on any of the any sort of trial matching data or models, so we're literally using it out of the box. And if it's I'm working with a colleague to kind of figure out if there is a way in which we can go against some sort of a standard measure and figure out and index how this does compared to some traditional trial matching techniques. So if we were able to sort of reliably reproduce that some accurate data, I'd be happy to share in a future video. But let's just go through this demo, and I want to walk you through how this works. So like with anything in this interface, I first look for a condition or a disease, right? So I do that. Now, obviously, there is some restrictions on I only pull in the 5 studies. We talked about it in the previous video. In a production example, you don't have to have those kinds of limitations. But just a quick and dirty, let's first show you how the match all works. So when I click match all, here's what will happen. Um, the first study in this list would be taken in for the match. You can obviously change it to the UI, but the idea is it'll take the first study here and it will match it against 10 randomly pulled patients from the database that we the synthetic data that we pulled in from Cynthia, and it will spit out a match summary, if you will, and then you can sort of explore it further. So now that we have this data, if we just do match all, what's happening now is for that first study, it's getting all the patient data from the Azure managed Postgres instance. Now the LLM is actually doing the match based on the eligibility criteria of the study. You can actually see what the eligibility criteria of the study is right here. So we extract out the eligibility criteria based on real-time data that comes back from clinicaltrials.gov. And this is the match status for each patient that I talked about. So since this is a demo, what I do is I randomly pick 10 patients from our synthetic study database, and then run each patient's data against this eligibility criteria and have the LLMs spit out a match status. So it's actually pretty decent for a first rep. For example, for something that's completely untrained and sort of letting it reason over this data, as you can see, it says that this particular patient it's not able to define if this is a match. This one, it thinks that this patient is a potential match. However, further investigation is needed to confirm eligibility. It gives its reasoning for the match, right? The patient's age sort of falls here. The patient has locally advanced unresectable metastatic gastric adenocarcinoma, and then it sort of looked through some of the criteria for the study, and matched it with something that it found in the patient information. It again finds us some other potential matches. Um, you know, then it also kind of says to us what are some of the additional areas that this patient needs to meet. And in some of the cases, it basically says, hey, this patient does not um, meet. And here in this case, it says that it should be resistant and there is no information regarding this. So, think of this as a sort of a first cut through this, and maybe you use this to get some potential matches, if you will, that you can then maybe give it to a human investigator and have them look at it, right? So we can do further things, and this is kind of what I kind of show as well on this demo. If you're interested in a particular patient, you can just do explore further, and then what this does is this is just the same UI magic. It's nothing different. Basically, it on a single patient now. Um, um, you can ask more detailed questions and chat to see if this patient is a particular match. So you can also kind of see the conditions that this patient has. You can see care plans that they're on, any encounters that they had, medication, whatever information is available about the patient in the synthetic data or Postgres data. You can see it here, and you can ask further questions about that specific patient and get some answers. So a way in which we can leverage LLMs to do some initial matching to maybe yield a subset that we can then give it to human analysts. Note though, by the way, this is just a pure demo. The fields that I pick, and uh, they were sort of provided in a synthetic format, and then I do some sort of compression on this information, just to get it to a way in which I can feed it to the LLM. There might be you might use, based on your expertise, the right time frame, the right conditions. You might include additional things like location-based filtering and other things. But the overall idea is I wanted to sort of demonstrate that you could just, as a first cut, leverage the capability of an LLM by giving it an inclusion exclusion criteria and reasoning over a database of patients like this, and then just get an initial cut that you can maybe potentially give to for further investigation.